The universe is a vast and diverse cosmos, revealing its secrets through a variety of electromagnetic signals. To decode the mysteries of the cold and obscured regions of space, scientists and astronomers have built an extraordinary observatory known as ALMA, the Atacama Large Millimeter/Submillimeter Array. Nestled high in the Atacama Desert of northern Chile, ALMA has been revolutionizing our understanding of the universe by observing some of the coldest and most distant celestial objects in unprecedented detail. The concept for ALMA began in the early 1990s when astronomers and scientists recognized the need for a revolutionary observatory capable of studying millimeter and submillimeter wavelengths. These wavelengths offer a unique window into the universe, as they can penetrate the dense dust and gas clouds that shroud many celestial objects. ALMA represents a collaborative effort between North America, Europe, and East Asia, with funding and support from various countries and organizations. The project's ambitious goal was to construct an array of radio antennas equipped with advanced receivers and signal processors to capture millimeter and submillimeter radiation from space. ALMA's design and technical specifications are nothing short of awe-inspiring. ALMA is situated at an elevation of 5,000 meters, 16,400 feet, in the Atacama Desert. This location was chosen for its extremely dry, clear, and stable atmospheric conditions, which are crucial for millimeter and submillimeter observations. ALMA consists of 66 high-precision radio antennas, arranged in a variety of configurations to capture different spatial scales. The antenna's precise positions and flexibility allow astronomers to collect and combine signals effectively, providing high-resolution images. ALMA operates in the millimeter and submillimeter wavelength range, covering frequencies from 31 GHz to 950 GHz. This broad frequency range enables ALMA to study a wide array of astronomical phenomena, from the dust around young stars to the cool gas and molecular clouds in galaxies. ALMA is equipped with state-of-the-art receivers that can detect extremely weak millimeter and submillimeter signals. These receivers can operate at temperatures close to absolute zero, enhancing their sensitivity and accuracy. The ALMA correlator is a powerful supercomputer that combines and processes the signals from all the antennas, creating high-resolution images and spectral data. It can perform more than 17 quadrillion operations per second. ALMA's ability to observe at high spatial resolutions has allowed astronomers to capture detailed images of protoplanetary disks, star-forming regions, galaxies, and more. ALMA's technical capabilities have enabled it to make numerous groundbreaking discoveries and advancements in several fields of astrophysics. ALMA has revolutionized our understanding of how stars and planets form. It has provided detailed images of protoplanetary disks, revealing the birthplaces of planets and shedding light on the early stages of planetary systems. ALMA has studied dying stars in unprecedented detail, including asymptotic giant branch stars and planetary nebulae. These observations have expanded our knowledge of stellar evolution. By observing galaxies in the early universe, ALMA has contributed to our understanding of galaxy evolution. It has detected and characterized distant galaxies, tracing their gas and dust content, and investigating their star formation histories. ALMA's observations of molecular gas and dust around supermassive black holes have provided insights into the feeding and feedback processes of active galactic nuclei, AGN, helping us understand how these cosmic behemoths influence their host galaxies. ALMA has studied the CMB's polarization, providing valuable information about the early universe, cosmic inflation, and the structure of the cosmos. ALMA has probed the atmospheres of exoplanets, allowing astronomers to analyze their chemical compositions and study the physical processes occurring on these distant worlds. ALMA's future is bright, with numerous advancements and projects on the horizon. ALMA continues to accept proposals from astronomers worldwide, allowing them to conduct research on a wide range of topics, from planet formation to galaxy evolution. Expanding the observatory's capabilities, Band 1 and Band 2 receivers will enable ALMA to observe even longer wavelengths, offering new insights into molecular and atomic gas in galaxies. ALMA is poised to study the Sun, capturing images of its surface and probing the magnetic fields and physical processes responsible for solar activity. Ongoing efforts to improve data processing and analysis techniques will further unlock ALMA's potential, facilitating the discovery of new phenomena and the study of known objects with unprecedented precision. The Atacama Large Millimeter/Submillimeter Array, ALMA, is a testament to human ingenuity and international collaboration in the pursuit of scientific knowledge. Its cutting-edge technology and unparalleled capabilities have revolutionized our understanding of the cold, dusty, and distant regions of the universe. As ALMA continues its mission of exploration and discovery, it serves as a source of inspiration for astronomers, astrophysicists, and space enthusiasts worldwide. Its keen 4mm and sub-millimeter wavelengths provide a unique perspective on the cosmos, allowing us to unravel its mysteries and expand our knowledge of the universe's rich tapestry of celestial phenomena. ALMA's future is as bright as the galaxies it observes, promising continued revelations about the universe's coldest and most enigmatic corners. And that's all for today. Hope you liked the video. Stay connected to get more knowledge about the space. Please like, share, and subscribe to our channel.